on page 52. So real quick here, this polygon right here has 11 sides, okay? Let's identify one interior angle. So you go to any corner, you make a little arc there, and you put the letter I is probably preferred because that stands for interior angle. The exterior angle would be simply extending one of the sides, and right next to it, put a little E there. Central, right, you go to the center and just cut out a slice and make sure you put central angle there. So that's how you label and identify those three. To find the sum of interior angles, we would simply go 11 minus 2 times 180. That is 9 times 180. That is 1,620. So the more sides you have, the bigger this number is going to get, because you've got more interior angles that you're adding up, right? So this number does go up significantly. Interior angle is n minus 2. I'll just copy paste basically, right? I'll copy paste this. It's n minus 2 times 180 divided by n. So this is really 1620 divided by 11. Please make sure that you understand that your interior angle can be a decimal, right? So these can all be decimals. That is how a measure of one of these interior angles. Exterior angle is simply 360 divided by n. So that would be 32.73 degrees. Don't forget the degree symbol if you want to get full marks. Central angle, one of these, is calculated the same way. Someone just asked me, are they always going to be the same? If it's a regular polygon, yes. They are always going to be the same. Okay. D, number of diagonals, that would be 11 times 11 minus 3 divided by, not n, but 2. Okay. That's 11 times 8 divided by 2, and that's 44. You can just leave it like that, or you can add diagonals. So there's 44 diagonals that you can draw all across this shape. Okay. So make sure you have at least one more. If you're into highlighting, I would say that the 11, you should know where the 11 came from. Wherever there's an 11, it has to do with the number of sides. Okay. So number of sides is what gets all of these going. Let's go down to the last question on this page. What is A? If I asked you for A, what angle is that? Yeah, there we go. That's all I need you to know. I'm not going to solve this. I'll just tell you that A is supposed to be 156 degrees. C, what's C? Exterior, yes. I can just go 180 minus this, right? And get it that way. Or I could go 360 divided by how many sides? 15. So any way you choose, let me just get this straight here. 24, right? 24 degrees. So that's what you're supposed to. So this is an interior angle. This is an exterior angle. And here's where the tricky part is. I wanted to see if you were awake today. B is a? Look carefully. Central angle is involved here for sure. Two sides, you see that? Why you trick us? You just have to go and ruin it for us, right? There's a central angle here and there's a central angle there. So B is essentially two central angles, all right? So angle B is 2 times that, right? 2 times 24, it's 48 degrees. So I don't know what the province is going to do. So just be careful. Don't just assume and jump right in and assume that that's what it's going to be. So just keep that in mind, okay? I would like you to do that whenever, if you have a chance, go ahead and do that. If you go to 53, can you go to 53 real quick? When time is not a problem, I'm like, hey guys, this is our activity. Let's fill in this whole thing. Let's find psyched for all of them. And I'm like, you know what? We're not going to do that. You don't have to worry about that right now. I just want you to know these here, the number of sides and the prefix that goes with the number of sides. So 3 is a triangle, 4 quadrilateral, 5 pentagon, right? 6 is a hexagon, heptagon, and so forth. Don't use too much space, but this is why you need to know this. Sometimes they make you calculate the number of sides of a polygon, and they ask you, B, what is this polygon called? And you're expected to know all the way to dodeca. And you know what I always ask myself, and I just make up stories, okay? It's probably not true, but what happened to 11? What happened to 11, right? So my theory is, this was like Friday, 5 o'clock, like almost end of shift. So they were like just trying to kill time, come up with their 10, right? And, oh shoot, we gotta go. We gotta go up to 12. Like, forget 11, just do dodeca, let's go, right? So that's probably what happened there. But there's no name for 11. So deca is your 10. Decade, think of decade, right? Decade, that's 10. Nona, think of 9. Octagon, right? Okay, so hexa and hepta are sometimes mistaken. Hexa is 6, hepta is 7. So if you could, very, very small, have this on your study sheet, I will just write that down, study sheet. Most of the time it's easy ones, like hexagon seems to be a very popular, pentagon, so I haven't encountered the dodecas yet on an exam, but you can never rule that out, okay?